Hello everyone, welcome to my channel. Today, we will talk about convolutional operation. It is a very common operation in computer vision tasks and in deep learning networks. For example, let's consider an image classification task. We have an image with height h and width w, and we feed it into a model to obtain a probability distribution vector for the labels. So, what do we need to do? One popular approach to do it, this is to weight each pixel in the image. First, we need to reshape the image matrix into a vector and pass it through an ANN, artificial neural network, to obtain a probability distribution vector for the labels. However, there is a problem: if the size of the image increases, the size of the network also increases. Imagine an image with 1 million pixels, the amount of computation required would be enormous. And this is where the convolutional operation can help overcome this issue. The convolution operation, using learnable kernels, reduces the spatial dimension of an image while extracting features through the kernels. These extracted features are referred to as feature maps. The convolution operation is performed by sliding a window of the kernel over the input image. At each window position, the window region values are element-wise multiplied or matrix multiplied with the kernel. The result of this multiplication is the corresponding value for that window position. The convolution operation is actually a matrix multiplication. We will explain this in more detail in the following example. Let's imagine that the window region is flattened into a one-row matrix, the kernel is flattened into a one-column matrix. This is equivalent to performing a matrix multiplication. In this case, the 1/4 matrix is multiplied by the 4/1 matrix, resulting in a 1/1 matrix, also known as a scalar or a single value. So what about higher dimensional images? The next example will illustrate convolution in more dimensions. Typically, an input image has 3 dimensions, R, G, and B. The convolution process combines information from these 3 dimensions. We can generate multiple feature maps by using kernels with higher dimensions. This operation is important as it helps us extract various types of information at the same time. We can use this information for classification purposes. Convolutional operation serves as the foundation for subsequent deep learning models. These models continue to emerge, inheriting and addressing the limitations of previous models. With each new model, we are required to make relentless efforts to keep up with technological advancements. This is the first installment in my series on convolutions. If you find it interesting and informative, please like and support it, as it means a lot to me. Thank you very much.